Hi everyone, welcome to my video on building a solar system app using RealityKit. Before we jump into the code, I'll show you a quick demo so you can see what we are creating. In this video, you will learn how to make an entity, how to add one or more textures to an entity, how to create infinite orbit rotation. I'm making this app because it's easier to learn about the solar system when it feels like it's right in front of us. First open the Xcode. If you don't have it, you can download it from the App Store. Now create on a new project and select augmented reality app inside the iOS section. Click on next. Write your product name or your project name. I am going to write it solar system. Select your team from the drop down menu and write your organization identifier to your name or your organization name. Set interface to SwiftUI, set language to Swift, and choose content technology to RealityKit and click on next. Now choose location where you want to save your project and click on create. Okay, so now I am going to remove this canvas and also remove this code also. Okay, so now save it, and I am going to build this project using command B command, and you can build it from here also. Command B short key and click on build. Okay, so now let me explain this reality view. Reality view is a Swift UI view that enables you display and manage 3D content using RealityKit in your app. And what is this content? Content is like a container. Any 3D objects like a sphere, square, or anchors that you want to see in the scene, you just need to add them to the content and they will appear in the scene. Let me show you an image to explain this more clearly. As you can see, we have a sphere, donut, and square. All these objects are added to the content. Let me first add all the texture to the image set that we will use to create our planet app. I have already downloaded all the textures that we will use to create our planet app. All these textures I will use to make our planet app. Okay, so now click on first assets, and inside the asset catalog click on plus button and select new image set. and give the image set a meaningful name. I'll call it Earth Map, and simply drag and drop your Earth Map image here in a appropriate slot. And there you have it. Your Earth Map image is now added and ready to use in your in your code. Okay, let me quickly add all the textures that we will use in our app. All these textures I'm going to add it. Added all the textures. All these textures we will use in our planet app, solar system planet app. Okay, so now let's load the earth texture we added earlier. We will write a small block of code that does four things. First thing is it loads the image. Second is wraps it as a texture. It as a texture. Third is create some material. We will create material our on top. Creates a material and assign the image to the material's base color. Base color. Assign assign the image to the material's base color. Okay, so let me write if let earth texture resource equals to texture resource named I will use only named. Remove this and remove this also. Named is that we added earlier earth map. So first we try to load the texture named as earth map from our app bundle. This is the image we added to our asset catalog earlier. Texture resource loads the actual pixel data into memory so RealityKit can use it. Since this is an asynchronous operation, we use await, and we use try also to avoid any errors. And I have used if because I am going to check if this earth map is load, then we are going to do other task. Now let's write let now I am going to wrap this image resource as a texture. Let me write let earth texture equals to material parameters dot texture, and write this one here. Once the image is loaded, we wrap it in a materials parameters dot texture. This is the format RealityKit expects when applying a texture to a material. Now I am going to create a material. First, var material equals to physically based material. Physically based material. This type of material mimics real world lighting and is great for making realistic objects like a planet. Now, lastly, I am going to assign the image to a material's base color. So let me write material dot base color equals to physically based material dot base color texture is earth texture. That's it. This block of code loads an image and turns it into a realistic material you can apply to any 3D model. Okay, now let's create a 3D sphere. Let me write let sphere mesh equals to mesh resource dot generate sphere, and I'm going to give it the radius is 0.06. Here mesh resource is a class from RealityKit that helps us create a shapes. We are using its function called generate sphere. This function creates a 3D sphere and we give it a radius as input. In this case the radius is 0.06 meters. This line only creates the shape. Now we need to add this shape and a material to our entity. Now I am going to create a entity also. Let entity equals to entity. So now I am going to apply the mesh and the material to our entity. Let me write earth dot components dot set model component, and I will use here our sphere mesh, and the material is this one. Okay, our entity name is entity, not earth. That's it. This line sets the model component for our entity. We pass in the mesh we created and material we want to use. Now the entity has a shape and a appearance, and it's ready to be added to the scene. Now let's add our entity to the scene. You just need to add the earth entity to the content so it appears. So let me write content dot add our entity. That's it. Now let's add camera tracking also. Content dot camera equals to dot spatial tracking. Okay, spelling mistake. Spatial tracking. And finally, this line allows the content to extend beyond the safe area, covering the entire screen. Okay, now let me show you the result of our app for right now. Okay, now let's run our app and see what is happening right now. I will use screen mirroring to show you the result. Let's run the app first, and it is installing app inside my iPhone 12 mini that is already connected. Okay, so I'm going to follow these steps so that our app run perfectly on our physical device. Okay, let me use screen mirroring to show you the result. My phone is showing to you on the screen. Now let me run the app. As expected, our earth map, earth planet showing on the word origin position on zero position. So let's write the code to apply the roughness texture also to our earth. I'm just going to copy and paste this code and rename it roughness texture resource, and let me see what is there for name for earth roughness. Okay, copy and paste here earth roughness and earth mm, roughness, sorry, let me write roughness texture only. Okay, roughness texture, and copy and paste this variable here, and copy this variable here, and rename it to roughness, and here also roughness. That's it. Let's try running the app and see what is happening right now. Command V to build and command R to run our app. As you can see, I have already connected my iPhone. Let me run the app. It is installing. As you can see, our roughness texture is added to our earth planet. Now I am going to add cloud texture to our earth model also. Okay, so let me copy and paste this code again and paste it here. Now right here cloud texture resource, and let me see what is, yeah, earth cloud. Okay, just paste it here, and cloud texture right here, cloud texture, cloud texture, and copy and paste it here, and copy and paste this one here. Okay. Now let me rename it to emissive emissive color, and write rename it also emissive color. That's it. Now let me run the app again and see what is happening right now. Command V to build and command R to run the app. It is loading. Oh, let me show you what is happening right now. Wait a minute. Where did the base color of the earth go? Okay, no problem. I know how to fix that. The emissive texture is currently too strong, so we will reduce its intensity. Let me stop screen mirroring. Now let me write only one line of code. Material dot emissive intensity equals to 0.1. By setting emissive intensity to 0.1, we reduce the glow effect, so it is blends nicely with the earth base texture underneath. Now let's run it again and check the result on screen using screen mirroring. Okay, awesome. Now it's look good. The emissive texture is currently awesome. The earth looks even more realistic with soft cloud layers. Now you can see that a lot of code will repeat when we start adding other planets. To avoid that, I am going to make a function. But before that, I'll create a struct to hold our textures in a single variable to keep things organized. Okay, so now let me write our struct first. I'm going to write our struct. Let's name it planet textures and make variables var base color of type string and make it optional. Var roughness of type string, make it optional. Var emissive color of type string also. That's it. Okay, let's write the function now. Hmm, I'm going to write function here. Func create planet, and I will take the input of our texture first. So planet textures of type planet textures, comma radius also of type flute. and I am using async here because loading texture is asynchronous, and it will return an entity. Now let's just copy and paste all these code to our function. Hmm, one by one. First create our planet. First create our material. Now let's copy code for base color, and let's add the command to base color texture. Remove these comments. That's it. And let me add one more condition here. If let base color equals to texture, sorry, planet texture dot base color. Okay, so if I am having base color into my planet textures structure, then I am going to add this base color here. That's it. In the same way, I am going to copy and paste this code also and write it here. And let's remove these comments first, and let's write here roughness texture. That's it. And let me write if roughness equals to planet textures dot roughness, then I will add this roughness here only. Okay, so let me know what is happening here. What I have added roughness. Okay, sorry. If let. Okay, now I am going to copy and paste code for emissive color also, and remove these comments. Let me write here only emissive color. Okay, now if let emissive color equals to planet texture dot emissive color, comma, that's it. Now let's create entity. Let's copy this code and paste it here. Create entity. Okay, Now let's copy and paste this code also, sphere, and copy this code also. Now just need to return our entity. Okay, now let me remove all this code from here. Now let's create our earth planet using the function that we have made earlier, this one. Okay, so now let me create first our earth textures. Let earth textures equals to planet textures. Let me first add base color of earth. Just copy and paste earth map. Now let me add roughness also. Roughness, earth roughness. And let me add our emissive color also. Just copy and paste it here. That's it. Our earth texture is ready to pass our function create planet. Okay, now let me call our function that earth equals to create planet, and let me pass this structure here, and the radius is 0.06, and let me add this earth entity here, and it is async, so let me fix it. That's it. Now let's see what is happening right now. Let's run the app and see what is happening right now. Command plus B to build, and command plus R to run our app. It is installing our app. Okay, so now as you can see, there is no difference. Using our function, our app looking good right now also. The difference is now we are creating our earth planet using our function create planet function. Let's add an orbit animation to our planet. I will write a function to add orbit rotation to our planet and explain each part as I code. Here is the function. Let me fold it first. Okay. Now func I will give the name is play orbit animation, and I will take inputs like for entity of type entity, and duration of type time interval, and speed of type flute, and spin clockwise of type bool. Okay, this function takes four parameters. Entity, this represents the 3D object or planet we want to animate, and the duration is this specifies how long the planet will take to complete one full orbit, and other one is speed, this controls how fast or slow the orbit animation will play. Spin clockwise, this is a boolean that determines if the orbit should be clockwise or counterclockwise. Now let's create an instance of orbit animation. Let me write let orbit animation equals to orbit animation, and I will add into this duration that I am getting from outside. Let me correct the spelling. Duration. Okay. Now I will add axis 1 comma 0 comma 1 comma 0, and next is start transform entity dot transform. I will explain all these. Let me write first. Now spin clockwise of type spin clockwise that I am getting from outside our function, and orient to path, it's true, and bind target dot transform, comma, repeat mode dot repeat, comma, last one is speed. Here I am getting it. Now let's break down the parameters. Duration, this uses the value we passed to control the orbit time. Axis, this defines the y-axis as the rotation axis, which makes the planets orbit horizontally, just like in the real solar system. Start transform, this takes the current position and orientation of the planet, so the animation starts from its current location. Spin clockwise, this uses the same boolean value to set the orbit's direction. And orient to path is set to true, ensures the planet stays oriented along its orbit path, similar to how a car faces forward on a road. Bind target dot transform, binds the animation to an entity's position, rotation, and scale. This ensures the animation directly affects how the entity moves, rotates, or changes size. Repeat mode makes the animation loop infinitely, simulating continuous planetary orbits. Speed controls how quickly the animation plays. Now, let me write if let generate animation equals to try animation animation resource dot generate with orbit animation. Okay, let me first correct this animation and paste it here, orbit animation. Now let me write first, I will explain this also. Let me write, after that I will explain it also. Entity dot play animation and copy this one here only. That's it. I am generating the actual animation using animation resource dot generate. The try. Ensure the app will not crash if there is an error. It handles it safely. If the animation is generated successfully, we use entity dot play animation to apply the animation to the planet, making it start orbiting as soon as the app runs. And that's how the play orbit animation function works. Now let's add an orbit animation to our planet. Now I'm going to add our this orbit animation to our Earth. Let me write play orbit animation. Entity is our Earth. Duration I will give it for 10 and speed is 1.0. Spin clockwise is true. That's it. Now let me run this app and see what is happening right now in our app. Command B to build and command R to run our app. I'm using screen mirroring to show you the result also. Our app is loading. Yeah, it's loaded. Let me show you. It's amazing. As expected, our Earth is perfectly rotating. We explained everything. Let's add other planets and their positions along with their rotations. Okay, so I have added textures for our all planets. These all textures I have added already, and I have made some mistakes. First, this should be create planet, not create plate. Okay, let me rename it planet and copy and pasted first here and rename them also. Create planet and other mistake is I have not used this one. It should be here. And another big mistake is I have used this hard coded value. And here should be this radius. Okay, that's it. After create all planets, I have set these their positions. All planet positions I have set, and make the moon child of the earth, so that this moon can rotate around the earth. And I have added the rotations for all our planets, and I have added these planets to our content. That's it. Now let's run the app and see the final result. Let me build the app and run the app. It is loading. I will show you the result using screen mirror. First, let's load the app. Yeah, it's loaded and running perfectly. Let me show you the result also. Awesome. We have a beautiful solar system with these planets all rotating in their orbits. Okay, so thanks for watching. If you enjoyed this tutorial, don't forget to like, comment, and share also, and and subscribe my channel also for more AI development content. See you in the next video.